All right, thank you, Margie. So thanks for that introduction. I'll introduce myself a little further. My name is Kyle Talbot. I'm a solution engineer with the Esri Imagery and Remote Sensing team. So what that means is we're a cross-sector team, and our team focuses on sales and business development, specifically in the realm of of imagery and remote sensing. So I'm a solution engineer that primarily works with the national government, and I don't have any specific accounts that I'm tied to. My role is to go in and provide support when all of your account managers need additional support when it comes to you all working with imagery. So I'm happy to be able to present with you today. On the line with me, as well as Kurt Schwope and Tim Muckey. They are account executives on the imagery team. They'll be able to help answer questions that you type as I'm presenting today. Very smart guys. They'll be very helpful with that. All right. So, the title of the webinar is Imagery and ArcGIS. Now, Esri has really stepped up their imagery game in the past decade, and we're no longer just the GIS powerhouse that we've been known to be. So covering all of our imagery capabilities in the next hour and a half really just isn't possible. So what I've done is I've broken the webinar into some of the essentials that we'll cover. I'm going to try and cover some of the things that are new that should be of interest to you all, and some of the things that we have been doing for a while, but you may not be aware that we're working with this. So we're going to start off the agenda today by going into imagery in the ArcGIS platform with a focus on Image Server and the role that it plays. Then we're going to jump into imagery in ArcGIS Pro. It's important to distinguish here the difference between just working with imagery in Pro and then the image analyst extension. There are things you can do in Pro today without the extension to support your imagery workflows, and then we'll cover later some of the additional things that you can do with the image analyst extension. Then we'll take a look at imagery in the web, focusing primarily on a new application called ArcGIS Excalibur. Then we'll have a break for questions. We'll try to do that at the 45-minute mark, but we may go a little longer. And then after the first question break, which will be about 5 minutes, we'll move on to what we're doing with drones, the products that we're able to produce with them, and the software used for that. And then at the very end, we'll briefly cover LiDAR and how we're able to work with it as well. It's not imagery, but it fits within the whole remote sensing program. And then we'll finish off with a final Q&A session, and that should be an hour and a half. I hope so. It's a pretty ambitious schedule, but I think we can make it through. All right. So as I said earlier, we've been integrating imagery very steadily into the ArcGIS platform. Really kicking it, really digging deep into it within the past decade. Imagery has often been considered a separate science from GIS, and it really shouldn't be viewed that way. Both GIS and imagery play a powerful role in supporting one another, and so we really don't have just one app for imagery. We have imagery that's integrated across the entire platform, providing a system of record for it with our imagery management, a system of engagement to access imagery, and system of insight, the ability to perform analytics on it. So we'll take a look at the overall imagery platform really quickly. The architecture can be overwhelming to some. For the most part, it starts with Pro. For some, this may be all that you need, but if you want to do more with imagery, Pro is many times the access point for publishing imagery to the server and thereby creating imagery services, and we'll go into that in a little more detail. But photogrammetry is used to make those sources accurate. Analytics can be set to run at scale and do all kinds of advanced analysis. And then users can access all of this content in powerful web applications like Excalibur. And we can display imagery information that we get from all of these derived information products from this imagery across the platform in story maps or operations dashboards. So this is what we're saying this is what we mean when we're saying this is a comprehensive imagery platform. So rapid access to your imagery and scalable processing is at the core of our image management. Now, as the imagery needs of your organization will grow, it's important to have proper image management. It starts with our data model for imagery called the Mosaic dataset. Now this Mosaic dataset lets you quickly access any image pixel at any time within your entire archive. Now this is different than accessing an image file. While the Mosaic dataset knows where all of your files are and maintains all of the metadata associated with those files, the modern imagery user just wants to work with pixels that cover the area of interest. And it doesn't matter if those pixels are coming from one image or 100 images. So, and all the visualization processing functions that you can run on a single image, they can also be applied to a Mosaic dataset that stores many different images, points to many different images. Now you can store all of these managed datasets locally in a shared drive wherever you're working, but you also have the option to harness the power of the image server to make your imagery accessible across the entire suite of ArcGIS software. Now, ArcGIS Image Server is a product that is part of ArcGIS Enterprise, though it is licensed separately. It can be deployed on its own server and federated to the entire enterprise, to the rest of the enterprise, which allows it to harness its full power. Now, the image server gives you two primary functions. First, it allows you to create fully dynamic image services. And these are more than just tile layers that people are most accustomed to working with in our base maps and other parts of the web. Those tile layers do not provide all of the data associated with each pixel, or simply put, they provide a picture of the picture. Now, while the image server does let you produce these tile layers as well, its real power is to produce image services. Now, these services provide all the data behind every pixel, and they can be used just like the full image product without needing to download the image locally. It can remain on the server and can be accessed and used by many people simultaneously. Now, this slide covers capabilities and scalability of the image server. What I mostly want to call attention to is the other primary function of the image server, which is raster analytics, and you can see that portion in black. Now, analysis has traditionally only existed on the desktop, relying on the cores on your local machine to produce the results. Now, raster analytics in the image server takes these same tools that have been traditionally been desktop oriented, brings them to the server. So the capability can be scaled across multiple servers. So a high-powered architecture can now take large-scale analytics processing and significantly decrease the times that it takes to get results of raster processing. And then that ties in as we'll see in the next slide, once these services and raster analytics have been created, you can share them and utilize them throughout the ArcGIS platform. This is how all of the imagery content that you get in the Living Atlas is delivered to your apps. You can do it now with your own data. So you can ingest these analytics or the image services themselves in ArcGIS Pro in various web apps, story maps, etc., mobile devices, to be able to visualize and process these various image services. So that covers our intro to the platform. Now we're going to dig into imagery in ArcGIS Pro. We're going to start with what you can do just with an ArcGIS Pro license. So I imagine that many of you are familiar with ArcMap. Some of you still may be less familiar with Pro, so we're going to take a closer look at it. Now, from an imagery standpoint, Pro is far superior to ArcMap, and that's because from day one, it was designed to work with imagery. Unlike ArcMap, where, to be honest, imagery was kind of an afterthought, imagery was considered from the beginning with the development of Pro. ArcMap just doesn't have the processing muscle or graphics capability to work with imagery quickly or efficiently. So the simple interface makes it a lot more user-friendly as well. All of the imagery tools are located together, either in the imagery or in the layer tabs instead of scattered throughout, like in ArcMap. It's connected with your GIS, so the information will benefit one another. There are measurement tools that are based on sensor model. We'll show those a little bit later for higher accuracy measurements. You also have the ability to link 2D and 3D views together, so you can view your imagery in both 2D and 3D scenes for better situational awareness. It's set up to support imagery-specific workflows, and with portal integration, as I stated earlier, you can easily bring in these image services and work with them in Pro, just as if you were working with local imagery. Now, Pro gives you access to the catalog, which is where you can manage all of your imagery. Image management is very important in important part of Pro. Again, you can create and organize and work with all of your mosaic data sets, whether those be local or whether those exist in the cloud or on the image server as image services. You're also provided with a raster items explorer to be able to better manage and understand what individual images are contained within those mosaic data sets. And then ArcGIS Pro provides some out-of-the-box analysis for working with imagery. So one of the highlights of ArcGIS Pro are the raster functions, which create in-memory results using on-the-fly processing for fast analysis. These raster functions can be chained together, just like in Model Builder, to create custom tools and workflows for easy replication. And because Pro is connected to the portal, you're not only connecting to the image server for ingesting all of your image services, but you can also harness the raster analytics portion of the image server to scale your processing from the cloud in Pro, perform large-scale analysis much faster than you could locally. So we're going to stop now for our first demonstration. I'm going to show you, again, these are things that you can do with imagery in ArcGIS Pro today, whether you have the image analytics extension or not. So first I'm going to show you adding imagery from a local folder. So here I have a Landsat 2 or Landsat 8 image over over upstate New York. You can see that as I've downloaded this Landsat image, that I have many of the different bands, individual bands here from Landsat, but I also have a completed image product that they've given me. And ArcGIS Pro recognizes that. You can see the little satellite symbol over the raster symbol. That means that it recognizes that it's a full raster product. And because it's a raster product, Pro reads the metadata and can do some pretty powerful stuff with that imagery. So once it adds, you can see it recognizes its geospatial reference automatically, puts it where it's supposed to go. We see this really annoying dark black background. So one of the first things I'm going to do is just go to the Appearance tab, click Symbology, and I'm going to mask out this background value. And you can see that I've set all my band values that are at 000 to display no data. And so now I can just work with the image itself. Pretty easy, simple to do. I can change the base map to be an imagery base map so that I can see how that compares, see how my Landsat image compares. One of the things that I'll show is our ever popular swipe tool that allows me to make comparisons from one image to another with a simple swipe. There are various tools here that we have access to in the Imagery tab. So all of my raster functions that I want to work with, they're available here. I have access to them in the tab. There's over 100 that you have out of the box that you're able to use. All of my high accuracy mensuration tools that are available and reading the correct metadata from the image are available here, as well as some georeferencing tools that I'll show here in a minute. I can work with the appearance here as well, so I have some enhancement tools for for different contrast settings. And because this is a complete image product that Landsat produces, I have various band combinations that it's reading reading automatically from this raster product. So I can change it quickly from natural color to infrared. I can change it to a land use setting, and you can see it's automatically adjusting the different bands. I can go and select the bands myself, which ones that I want to work with, but these band combinations that are used for different land use purposes from Landsat are very helpful. And then you're able to create your own custom ones as well and add them to each product. I can change the stretch type here. And then one thing that I'd like to show really quickly is our charting capabilities. So I have the ability to create spectral profile charts. And what I can do here is I can select a point on the map, and what it will do is it will tell me what the spectral profile is of each point within a chart, so that I can understand what type of land cover, what type of material that I'm looking at. This is really pretty fascinating to see when you're working with hyperspectral imagery, and you can see the changes across hundreds of different bands. But it works pretty well with Landsat as well across its 8. So that's working with local imagery. I'm going to come really quickly and show you how you can work with image services as well. So I was able to pull that Landsat image from a local folder, but I have access to my portal as well. You can see here I'm logged in with my user identification to my portal. And if I search my portal for different items, I'm looking for an image service over Detroit, you can see that I've found an imagery layer, the imagery layer that I'm looking for. And I can quickly add that to my map, begin to work with it. Now, it looks like a single image, but if we look at the attribute table of this service, we can see that there are many different images that are associated with it. A lot of different overviews, actually, as well as some individual rasters. Now, looking at it in this attribute table isn't necessarily easy, so I'm going to go into the data tab and I'm going to explore my raster items. What I'll do is, because I just want to look at the different rasters and exclude the overviews, I can select that, and by selecting all of the rasters, I can now get a better look at these rasters one by one. And so if I come into the inspect, it lets me see the different metadata components of these images as I select them. And then if I want to work with a single image instead of the mosaic data set as a whole, the service as a whole, what I can do is I can add these individual rasters to my current map as an individual file. It's still a service and it's still tied to that mosaic data set, but now I have a single image that I can work with and use just like any other image. So pretty powerful stuff. We also have some georeferencing tools that are available. So if I were to add, we'll go over this quickly. If I come back and I add some imagery that doesn't have any spatial reference, you'll notice Pro gives me a warning that I don't have any georeference to this. So you'll have to trust me, it's sitting at that infamous 00 out in the Atlantic Ocean. But if I go in and I understand where I need to, more or less where I need to place my image, I can come to the imagery tab, open a new georeference session, and I can fit this image that I have selected to the display. And you can see it kind of fits over this area. This is some historical imagery over Portland, Oregon. But you can see right here that this road here is not matching up appropriately. So what I can do is I can add different control points. I know that this building, this endpoint and this endpoint are supposed to match up. And so it will automatically adjust to that new point for me. And you can see as I start to add some more points, we'll do it with this point of the building, turn off the layer, match it with the base map here. And now it's automatically going to adjust that. You can see that it's starting to fit much better. So very easy georeferencing tools if you have unstructured, unreferenced imagery. The more points that you add, the more accurate this is going to get. But you can already see that it's starting to fit much better than what it was. And then the last thing I'll show you is working with a full mosaic data set. So this, I'll open up the attribute table. This is a local mosaic that we're working with here of planet imagery over California. You can see here we have over 250 images in this mosaic data set that we're working with. Now, I went and previously pulled out, for the sake of time, using that same raster items explorer that we showed. I used it to go ahead and pull out two individual images from this mosaic data set that we'll zoom into here. What I want to show you here is working with raster functions. So with this planet imagery, one of the things we can do is run some NDVI analysis over this area. You can see much of the area is agricultural, so we can get some good information from this. Now, as I stated earlier, raster functions produce in-memory results. And so what that means is it's not like a geoprocessing tool where every time you run it, it generates new data that, a new output that gets saved and stored somewhere. What it's doing is it's creating an in-memory result based on on-the-fly processing. So it's only giving me the pixels of this NDVI result as I need them, which means it's able to generate this very fast. So in the past, raster analysis has taken a long time because it takes a long time to generate an output for every pixel. But now with these raster functions, it's all done very quickly. And so I can generate these NDVI results almost in the blink of an eye. So I can do this individually on each of these images, and we'll use the swipe tool again here just to show you the difference between the two dates. But I can also apply these raster functions to the mosaic data set as a whole. So we'll turn back on the mosaic data set, and we'll go back out to the start. So in the data tab of the mosaic data set, you'll be able to see these various processing templates. Now you can make these fairly simple. You can make them similar to the band combinations, or if I just want to show the difference, change the different band combinations, I can do that. However, we also have the ability to add custom raster function chains as processing templates. So for example, we have this NDVI colorize where we've actually implemented this raster function directly to the entire mosaic data set. And these chains can be as long as you want, include as many different raster functions as you want. But what that does is it lets me do on-the-fly processing to the entire mosaic data set. Now it's not processing all of these, every single pixel of every image in the mosaic data set at a time. It's just giving me the pixels that I need. So it's very fast. So that is an introduction to imagery in Pro. This is what if you have Pro, you can do this today. So we'll jump back in to the demo. And now we're going to talk about image analyst extension. So you're able to enhance ArcGIS Pro with many extensions for advanced workflows in different areas. Spatial Analyst has existed for a very long time. 3D Analyst has been a big part of Pro. And so 2 years ago, we released the Image Analyst extension, providing the necessary tools for imagery analysts to work with all types of imagery, including traditionally non-mapping types. Now, many of the Pro extensions provide you with additional geoprocessing tools that do specific things. And true to that model, the Image Analyst extension does give you some additional raster functions, mostly those that let you apply mathematical functions to input rasters. But Image Analyst also focuses on bringing in types of imagery that provide essential information to GIS. But in the past have been harder to integrate. So let's look at some of these capabilities. For one, with Image Analyst, you're able to work with stereo imagery, so you can bring them in. You can create stereo pairs from mosaic data sets. It works with both shutter glasses and traditional anaglyph, red-green stereotypes. And what it does is working with Stereo and Pro, it allows you to get those accurate measurements, including 3D measurements, and then extract features from these stereo pairs that you can then use to create 3D cartographic features or simply 2D features and integrate them into your GIS. We also introduce with Image Analyst extension the capability called image space. So working with highly oblique imagery in a map has been difficult in the past because as you bring it in to a north is up perspective and geo-reference that, the objects in the imagery become skewed, as you can see in this picture right here. But with Image Analyst, you can work with the imagery and view it from the perspective of the sensor, and you can switch between that map-centric view and that image-centric view very easily so that you can work with your highly oblique imagery and capture your feature information correctly, including the capturing of objects as well as the appropriate measurements. Image Analyst also lets you work with full motion video. So this lets you integrate video files that are embedded with metadata information regarding the sensor location, orientation, and field of view. If your videos follow a government standard called MISB compliance, they're able to be ingested within ArcGIS Pro. And then Pro not only lets you view the image, the field of view and the sensor location in 2D maps and 3D scenes, but it allows for analysis, provides many tools for analysis that work, that help you get that information from the video into your GIS. We'll show an example of that a little later. We're also able to extend support for multidimensional rasters and data sets. So this is data that represents geospatial data captured at multiple times and multiple depths or heights. These data types are commonly used in atmospheric, oceanographic, and earth sciences. Now, Pro consumes multidimensional data on its own, and you're able to create and manage data sets without any extension. But with the Image Analyst extension, you get full access to all of the tools on the multidimensional data tab. So what this does is extent group lets you limit the different variables. Current display type allows you to change the slice that you're viewing within the map. And then there are different analysis tools that provide different functions for advanced processing of your multidimensional data, such as aggregation of different raster variables, finding anomalies in each slice, and estimating trends for each pixel along dimensions. Image Analyst also provides tools for image classification. Now this refers to the task of assigning different classes defined in a land cover and land use classification system to all of the pixels in a remotely sensed image. So you can perform both supervised and unsupervised classification. Both can be object or pixel based. In ArcGIS Pro, the classification workflows have been streamlined into the classification wizard. So a user with some knowledge in classification can jump in and go through the workflow with some guidance from the wizard. And then there are also individual classification tools for more advanced users that may only want to perform part of the process. And these outputs can be used to create thematic maps or be used as a supported data layer in a GIS. Now the pixel editor is a new function in the within the past year in Image Analyst extension. It contains a set of tools used to interactively manipulate pixel values for raster and imagery data, and it allows you to edit an individual pixel or group of pixels at one time. These are good for use cases such as editing elevation data to fill voids, It'll let you reclassify pixels, regions, or objects that haven't been classified appropriately. Helps you to obscure or redact confidential pixels, replace clouds, etc. And we'll show an example of that in a minute as well. And then finally, we've added various tools to Image Analyst that allow you to perform deep learning workflows to remotely sense imagery directly within Pro. And these can include things like prediction, classification, and object detection. One of the highlights now is that we have all the tools and external frameworks integrated within Image Analyst that lets you complete an end-to-end object detection workflow without ever leaving Pro, including the labeling, data prep, model training, and the actual detection of objects in the imagery, all within Pro. So there are a lot of fascinating problems which we're able to tackle with machine learning, which I don't have the time to get into details about today, many of which are imagery based, such as the object detection, not just from imagery, but from videos, being able to do things like smart road digitization, as well as object tracking and tracing. Should stress that some of these projects are more experimental than others, but by and large, these are all things you can do with imagery and remote sensing in the ArcGIS ecosystem today. Now, like our cross-sector imagery team that I mentioned that I was a part of, we have a dedicated GeoAI team at Esri that are focused on these workflows that can provide support for this. I do believe that they even have a webinar next month in the national government series that's focused on feature extraction from imagery. So if you want more information, I would highly recommend attending that session. With that, we'll go into a demo of some of the capabilities of the Image Analyst extension. We won't do all of them. We'll focus on some of the most exciting ones. So with image space, here we have a multispectral image over Rio de Janeiro. And you can see it was taken at a pretty oblique angle because we've got this mountain here that is crumbling into the ocean. We have all of these buildings on their side. Looks pretty rough in its current state. However, with Image Analyst extension, I have the ability to set this image as my focus image, and then all of my data is now being viewed from the sensor perspective, and you can get that sensor model information here in this information in the upper right corner. But now you can see everything appears how it's supposed to. This is very helpful for when I need to use my mensuration tools, so I can get information like from base to top height and get high accuracy information on that. It's also very helpful for capturing information about features. So if I move over to the airport in Rio, which is now using a panchromatic image, you can see that I'm able to capture accurately these building rooftop locations as well as the plane locations as they appear, so that when we switch back to the map-centric view, they appear where they're supposed to go. So that's pretty powerful stuff. That's just a brief introduction to the science that's going in behind that. Next, I want to show you the pixel editor, what it can do. Go back to our swipe tab here. And we'll show you that this is some imagery that's been through a classification workflow in Pro. And you can see that as the land cover has been identified, some clouds were in the way, And so they've been misidentified as water when this should be land over this area. So what we'll do is we'll move into this area and we'll open up in the Imagery tab, the pixel editor. And what this will let me do is select a class here, which we want to identify this area as shrubland, and I can reclassify it by pixel, by object, and by region. So what I can do with this now is I can draw manually the area that I want reclassified as shrubland, and it'll just do it automatically for me. I'll show you reclassifying by individual pixel as well, if you want to do it for more intricate fixing. And then let's move over to another cloud. Over here, I can also identify an entire object, which doesn't work as well for this workflow because I'm only identifying the water that it's picked up, and have that reclassified as shrubland. Really powerful stuff. And then the last thing that I want to show from Image Analyst Extension is full motion video. So again, we have this MISB compliant video. It's giving me, it has the appropriate metadata associated with it, and it shows me in this 3D scene the location of the sensor, its line of sight, and as well as its field of view. And so there are many different tools that I can use to display information from my GIS to the video, or from the video to my map. So I'm just going to show you two of those things really quickly. One of the things we're able to do is edit features directly in the video. And we'll turn on the synced graphics so you can see that. So as I drop points in the video, you'll see that they're appearing in the map where they're supposed to belong. The other thing that we're able to do is take frame snapshots from the video itself, and in a single click, we're able to save that frame as an image directly onto the map. Automatically georeference where it's supposed to go. So, Image Analyst, that covers that portion. Pretty neat stuff. All right. Before our first break, I want to quickly cover going over imagery in the web. We'll move through this very quickly. So with the migration of GIS to the web, we've been working with imagery for years now in both ArcGIS Online and Enterprise. We've been able to consume tile layers and image services in maps and scenes. And we've been able to build imagery-focused apps for various workflows in Discovery, and we've been able to do that using various templates and the web app builder. So this is an example of an app that we created with our own technology called the Landsat Explorer. It's a public app built on Esri, and what it does is it consumes a single image service. Oops. It consumes a single image service that contains all the Landsat imagery. Sorry about that. Let's try that one more time. Contains all of the Landsat imagery available to the public. So it lets you discover any imagery based on date and location, and it also provides some basic analysis. So for here, you're able to input your own feature layers and files to the Landsat app for references as you're looking at imagery. As he zooms into the area here, you'll see that he's able to change on-the-fly rendering, or so that you can better see the land cover. And then there are different tools for things like change detection and masking that will help you identify things like a burn index, let you adjust the accuracy of that. And then you can even save the layer so that you can bring it into different web maps and scenes in Pro, etc. So this is what we've historically been doing with imagery in the web. However, now we want to introduce some new web-based software called ArcGIS Excalibur, which allows you to integrate and enhance your image-based workflows for all of your image services within your organization in a single environment. So it allows users to easily search, discover, compile, and publish all of these image layers. It's designed for imagery analysts, imagery specialists, and even people who are not as advanced with ArcGIS Pro and advanced image analyst workflows. So what it does is it provides a simple, intuitive design that allows you to catalog your image services, discover what you have available in each service, and even filter search settings by things like date range, cloud cover, obliquity, as well, and image name as well. It gives you some basic analysis function and exploitation capability, like ArcGIS Pro, with the image analyst extension, the ability to view oblique imagery, both in the map space and image space, and provides tools for annotation and measurement as well. And then from the analysis in Excalibur, it allows you to create imagery-derived products. So you can create different briefings such as dashboards and story maps from these layers, and report on your findings from Excalibur. I want to jump into Excalibur and show you how that works very quickly. So with Excalibur, it gives you some options at the beginning of being able to connect with different image web services, directly connecting to your catalog, or searching in My Available Imagery. So again, I'm that same user in that same organization that I was in Pro, but now I'm connected to all of my image services in Excalibur. So I can look through these services here, pick the one that I want to work with. In this case, I want to work with this West Coast oblique image service connected to the catalog. When I connect this image service to the catalog, I run a search, and it'll show all of the different footprints. You can see that it covers a very wide swath all the way up from Washington down to California. So this doesn't give us a really good idea of everything that we can do or all that you can see. So instead, I'm just going to zoom down into Los Angeles, Long Beach area. I know I want to search for imagery over Long Beach. So if I run the search again, now I'm just looking at these image services over that area. So I'll concentrate my search even further, and now I can see these different image services that I'm working with. As I scroll over, the corresponding image highlights. I can preview what that image looks like here in the catalog. Make sure it's the one that I want to work with. I can preview what the metadata is of that image, again, just to ensure. And then I can take my queued images and connect them to the canvas. So you see, we're able to work with this image service. I have various different tools for this on-the-fly exploitation. One of the things you'll notice, again, the image is taken at an oblique angle. So we have the ability to work with this image, both in map space and image space. And we can even do that side by side. And these displays are linked to one another. So that as I scroll in one, I can see what I'm doing in the other. Again, we have some tools for basic exploitation. That includes measurements. So as I adjust, I can measure the length of this boat in the harbor here. It gives me that measurement. It also allows me to do some basic markups over this area. So I can do things like draw a bounding box around my area of interest, add some text. Again, this is for very basic exploitation of this area. And then from here, I have the ability to export these markups as a PowerPoint. So I won't show that. We also have some new tools in Excalibur. We're constantly updating its capabilities. This is a product that was just released at the beginning of last year. So we have some new capabilities, such as the swipe tool. What I'll do is I'll turn on the imagery base map layer. So the swipe function is now available for comparison. I can compare against the base map or against other images in my service. We also have a flicker tool that essentially does the same thing, just allows you to select play between the different layers and adjust the rate on how often they move back and forth from one another. One of the key capabilities of Excalibur, though, is the ability to create different image projects that let you save specific imagery and specific tools for the analysis of that imagery directly within a project, so analysts can have quick access to them. So this is a project that we created to show ammo storage observations with some imagery at an undisclosed location. Not classified imagery, just so nobody freaks out about that. This is completely unclassed. But what I'm able to do is I'm able to collect different observations. I can collect point, line, and polygon features over this area and save them out, quickly adding different comments and indicating different statuses and filling in the different fields here. Now, this is a fully dynamic feature layer here that is integrated throughout the entire platform. So as I have this feature layer integrated into dissemination material like this dashboard, when I submit this observation, it will automatically update here in the dashboard. So we can get accurate, quick, up-to-date analysis of the imagery out to the people that need it the most. So that concludes the Excalibur demo, and I think we're ready to take, we're almost ready to take our first break. Just wanted to highlight some of the new things coming to Excalibur in the next releases. Some automatic change detection workflows will be available. markup tools will get an enhancement. In future releases, you'll be able to upload imagery directly into Excalibur instead of just working with image services. We'll have some object detector workflows available as well. Excalibur is planned to be the place for integration with motion imagery once motion imagery hits the web, and as well as support for oriented imagery. So this is imagery that's taken at ground level. So those from phones, camera, from different, like the Google car, etc. All right, so we have time for some questions now before we move on to the next section. We can probably take about 5 minutes. Margie, did you identify any questions that were posed to the whole group?
Yeah. So this one will start with Excalibur. How do you access Excalibur? Through Pro or Esri Online?
Okay, yeah, good question. I skipped that part. You can access Excalibur from a web browser. It is an application that is directly tied to an ArcGIS enterprise deployment and an image server deployment. So it is harnessing the power of the image server. In your ArcGIS, in your portal homepage, you'll have an applications tab where you'll access things like operations dashboards and insights. That's the same place where you'll access Excalibur. Yeah, good question. Thanks, I did not cover that part.
Great. The next question is about stereo collection and how to do that within Pro.
Okay. Primarily, the way to do that is to create, if you have your stereo imagery collection, the best way to work with that is to place that imagery collection into a Mosaic data set. And once that imagery is in the Mosaic, you can then, there's a geoprocessing tool that allows you to generate stereo pairs, a stereo model from that Mosaic data set. And then it's a matter of when you go into insert a new map into an ArcGIS Pro project, you'll see an option. If you have the image analyst extension, you will see an option to, instead of add a map or a scene, you can add a stereo map. And that stereo map will then let you connect to any stereo pair that you have, and then that stereo map gives you the tools that you need, the very specific stereo tools for the analysis of that imagery. So.
Great. 2 more questions.
Great.
What does Pro have the capability to work with hyperspectral data out of the box?
So primarily right now, we are just ingesting hyperspectral data. So as I was showing with spectral readings, we can fully read all the spectral information in charts and in other ways throughout the ArcGIS platform, particularly within Pro. There are some additional tools for the management of hyperspectral data. Again, hyperspectral data works within Mosaic data sets, and so you can manage all of your imagery that way. Beyond that, we don't provide a ton of in-depth analysis for hyperspectral imagery today. That can change. We don't have anything specific on the roadmap. However, what we do offer is the ability to ingest different analytical functions from other platforms through our Python interface, and So if you want to be able to run some of those, some of that functionality from other platforms, from other providers, you can do that within Pro. Yeah, I think that covers hyperspectral.
Great, and last one for this batch of questions. Is there a way to have a batch process using the NDVI analysis tool?
Yeah, so yeah, you can, again, just like, just like you set up with your geoprocessing tools for batch processing, you can set up those tools as you create custom raster functions and custom tools to automatically run on new imagery as it comes in. On you can script that so that it just runs on multiple data sets. You can set up tasks to do that as well. Lots of different options. Short answer is yes. Yes, you can do batch processing. All right. So thanks, Margie, for the questions. Let me get a drink of water really quick. I've been talking for a long time, but we got half an hour and some of the really exciting stuff to finish off with. So this is an introduction to what we're doing with drones. So a few years ago, Esri came to the realization that low-cost commercial drones offered a new window into GIS. And up until this point, it hadn't really been cost effective to map these microgeographies using imagery. So what we decided to do was to create products that would accurately process high quality drone imagery into image base maps and other products that we would allow you to do a whole different type of GIS. The key to success is to keep the product simple and low cost. And so with that, we were able to move forward and a few years ago create Drone to Map for ArcGIS. It's been fantastic. It's been one of the hottest selling products at Esri, and been able to generate these products very easily. So these are the products that we're able to generate from drones in a nutshell. We're able to generate 2D products, so you can create orthomosaics, digital terrain models, and surface models and contours. We can generate 3D products such as point clouds and 3D meshes, and we can create inspection workflows as well for markups and making 2D and 3D measurements, all from your drone imagery. This is a little more in depth about the products that we create. You can identify that as these products for base mapping, such as the DSMs, DTMs, and orthomosaics. 3D products are good for site modeling and integrating into your 3D GIS, such as the meshes and point clouds and scene layer packages. And you're able to perform even some analytics directly within Drone to Map, such as volumetrics, annotation, and inspections. So this is Esri's current photogrammetric workflow. Again, we're going to focus on what we're able to do with drones. And the reason that we're focusing on our two drone processing pieces of software are that they use a different processing engine called Structure from Motion that allows you to generate those 3D products that we were talking about. So a traditional triangulation works best with photos that are nadir, that are horizontal, and they're best for generating those 2D products. Structure from Motion is a new and unique way of block adjusting these photos together so that you can create different products. And what it does is it takes photos from many different angles, not just nadir photos, and from that it recognizes unique spectral signatures in the imagery, and through that, taken at many different angles, it generates a point cloud, and that point cloud is what is able to generate all the different 3D products that you see. And so again, this is only available in Drone2Map, and as we'll show in a minute, our online, our new online software. So Drone2Map has a proven track record used by many different types of users to create imagery products. This is an example of one of our users at VCU that was able to collect 4,800 images covering a small airport in Southwest Virginia. He had a very powerful machine to be able to process all of this imagery at the rate that he did. But you can see that the resolution of this 3D scene is really powerful and helpful for local planners to better understand expansion of this airfield. So yeah, with his powerful machine, he was able to process this in about 3 days and get very, very detailed information of this area. I will briefly show Drone2Map because I want to focus more on our new SaaS offering. But this is Drone2Map. We released our 2.0 version of Drone2Map a year ago. This is 2.1, which has even faster processing times, up to 5 times different enhanced processing speeds. So you can go in and you can select the different project templates that will create different products for you automatically. When you create a project, you can give it a name and you can add different images to your project. So if I select this folder here titled Input Data, that has all of my JPEGs that were collected, you can see that the green check mark next to each image as I scroll down means it's identified the lat, long, and altitude of the photo. If I didn't have any if my georeference to the photos existed outside, it would prompt me to import a CSV or other file type so that it could recognize where these images were located. When I import these into a new project, this is essentially what it looks like. You can see that this project was taken, the flight path was using a back and forth pattern to capture the imagery. Imagery that I can view directly here in the map. So if I open up the image viewer, I can see each individual image here. But this particular image collect was more designed for 2D products, for creating that seamless orthomosaic, because it has that overlap that you see here. Once you have your input data, it will run simply on your flight data, the images that you've collected. You also have the ability to import ground control points using your ground control points manager for increased accuracy of these images. Once you have your options set, you can start processing the imagery, and these are some of the things that they will produce. So you can see this very seamless orthomosaic from that raw imagery. And again, if we change the base map to an imagery base map here, you're able to see how much better detail this imagery provides. Drone2Map has a new swipe tool as well. So this is an area in Redlands where we're constructing a new building. So you can see now the base map is more accurately updated to show what the process is at right now. But back when we conducted this this flight, this is what the construction was looking at the time. Even though the flight was not designed for 2D or for 3D generation, we were still able to produce a very highly accurate 3D mesh from this, generated this from the point cloud. And then there are various tools in Drone to Map that you can use for analysis of these areas. So we can go back and do some volumetrics in 2D and measuring of area, etc. And then again, because it's connected to the ArcGIS platform, you can share all of your outputs as feature layers, tile layers, scenes, or as entire web maps. Let's drone to map very quickly. So drone to map was great for many years, but one of the things that it was lacking was scalability, because it was only as good as the machine that it was running on. Our professor at VCU, he had a great machine. For anyone else who would have tried to have generated that imagery, myself included, it would have taken much longer. So store it, and in that regards, not just the processing, but storage has been an issue. Lots of images takes up lots of space, and so do the products that are generated from them. So like much of the platform migration has been in the past few years, with us moving to server-based software and imagery in the GIS in the web, we really needed to harness these capabilities of drone to map in the cloud to support large-scale projects and workflows. So at the end of last year, we acquired a product called SiteScan from 3DR. And what this does is it uses that same structure from motion processing engine as drone to map. So it does create the same products, but now it processes it in the cloud, and it stores all of your products there as well. So it's much faster, much more scalable, and you don't need to worry about storage either. It's unlimited storage. And again, this is our we've acquired it. It's now an Esri product, and so it's fully connected to the platform, and it scales with the rest of the organization. Couple other things that people have asked us over the years as they've been working with drone to map. They've been asking what drones work best, what drones are you able to provide drones? Now, we are still drone agnostic. That's important to note, that any drone imagery will work with drone to map, as well as SiteScan. However, now that when you're purchasing these drone bundles and packages, you do now have the option to add a drone as well. So as we've partnered with 3DR, we're able to provide their H520G drone. The drone itself, the specs are really good on it. Allows for stable, precise flight with its 6-rotor system. Has a very powerful camera that provides good video or still images. The real highlight here, though, especially for our national government customers here, is that the final assembly of the product was done in the US. And so with that, it meets the strict TAA guidelines and the government standards regarding security. So no need to worry about, it's not a, so simply put, it meets the non-foreign specifications, so that federal government users can work with this drone. Another thing that we've been asked to provide over the years is support for the actual collection of the imagery. And now with SiteScan, we provide a flight planning app for the iPad that makes flying and collecting very simple. Collecting imagery with all the right parameters may seem complicated, but the software really streamlines it. You're able to just select your mission type and resolution with your output imagery, and you can draw a box around your area of interest. And then from there, the flight management software essentially figures it out. And then once the mission parameters are calculated, the management software information uplinks directly to the drone. It takes off. Once it's complete, the drone flies back to its point of origin and lands exactly where it took off from. So we'll show you what that app looks like through a video. So what it does is you can open the app and you immediately connect to various projects. These projects are organized by multiple flights over similar areas so that you can organize all those flights over time. And so once you've connected to a project or you can create a new project, it allows you to connect to any drone that's in your fleet. Right now, the flight planning app primarily only connects with certain DJIs, but it also connects with that H520G as well. So you can connect to your drones and select flight plans. You can pre-existing flight plans that are already associated with the project, because if you're flying multiple flights over the same area, it's often good to keep that same flight plan. So you can dig into existing flight plans, edit them as you see fit. If you need to adjust the area, adjust altitudes of the flights, different hatch angles, as well as any different area that you want to add. The app lets you do that pretty simply with just scrolling. The app will briefly show us how you can create a new flight plan. We're going to do a perimeter scan. So instead of the crisscross back and forth imagery, these perimeter scans are better for processing 3D imagery, 3D products. So you can input a new flight name here. See if we can scroll ahead a bit. You identify your survey AOI, the area that you want to generate a 3D product from or 2D product from. It's pretty simple to adjust that area. And then once that's done, you can set your offset in the perimeter, and then it'll let you select your different parameters such as altitude, and you can visualize that altitude in 3D as well. So we'll skip the rest of this video. And instead, we'll move on to the actual site scan demo, what the site scan manager looks like in the web. So site scan, again, is accessible in a browser, just like Excalibur and other web-based applications. This is kind of our default intro page. You can see here down in the bottom left corner that again I am associated with the site scan is associated to my organization, and I can switch between organizations here. I can come to my full projects list here. Actually, before we do the projects list, I want to show all of my team members that are associated with my site scan organization. Team members are granted different capabilities based on their roles in the organization. So we have administrator, full access, read only, very similar to your roles in ArcGIS Enterprise. And so different members of the organization can be added to different projects based on what they need to do. So that bridge area that we were looking at in the in the flight planning video, we were able to process it. So you see we have two different flights over this bridge here, one collected in 2017, one in 2018. And we can show you some of the processing results from that bridge. So it gives us the orthomosaic generated from the photos. We can see the photos themselves, where they're located. Look at the individual images, download the individual images if we want to. And it's not just created the orthomosaic, but all of the same products that Drone2Map creates, the contour lines, the elevation models, cut fills, hill shades, etc. You have the ability to look at your flights in a timeline. So we saw that we had two flights over this area, so we're able to use a swipe tool to compare different flights over time. And then we were also able to generate a point cloud from this imagery. There's some pretty powerful analytics tools in SiteScan in the point cloud viewer. So I'm able to create an elevation profile based on the point cloud and understand where I'm looking at. I also have a really cool photo inspect tool that allows me to drop a point on any point within the point cloud and see all of the imagery that it appears in, all of the individual photos for inspection processes. And I can, again, download any of those images automatically. And then, of course, it also generates a 3D mesh over the area of this bridge. Give it a second to load. So you can see exact same quality that you were getting from Drone2Map, but now processed in the cloud. And stored in the cloud. I'll briefly cover how you can add new flights to a project or simply create a new project. So I'll do this in this California wildfire projects I've been working with. So if I wanted to add a new flight name, titled demo, today is 4/23/2020. What it'll allow me to do here is upload my different photos associated, and I can do this from somewhere local on my machine. Now, if I've used a flight planning app, what that flight planning app will do is, because I have it already tied to my different projects, different flights in that app, if I've gone and used that flight planning app, it will automatically upload those images directly into SiteScan and start processing them while I'm out in the field. I don't even need to go into the SiteScan manager to be able to do that. It will just automatically upload them there, and as I'm driving back to my office or wherever, it's processing. If I'm doing a workflow from the SiteScan manager, I do have to select my images locally. But once I do that, then it will start to manually check and make sure that these images are not duplicated in the flight, and then once it recognizes that, it will allow me to I can have these automatically processed once all of the images are uploaded into SiteScan. So once those images are uploaded again, then it will just, again, it will automatically process them, process the products, and it will alert me via email, actually, letting me know if the process is complete and what the results of the processes have been. So very powerful stuff. You can do your drone vehicle, your fleet management here as well, not just the vehicles, but the batteries themselves. And you can also, in your different projects, you can identify the different output settings to identify, just like in Drone to Map, what it is that you want to produce. So most important though, it's connectivity with the ArcGIS platform, of course. So not only can you export all of these products from the cloud locally via download, all of the raster data, your contours, point clouds, meshes, as well as the processing reports and the individual photos, but you can link directly to ArcGIS Online or ArcGIS Enterprise Portal and share this information as tile layers, scene layers, and feature services to the platform. So you can access them in your maps and scenes online, as well as in ArcGIS Pro. So that covers SiteScan. Really excited to introduce this product. It's got tremendous power and scalability, and we're excited to see what people can do with it. That covers our drone section. We are just about out of time. So I'm going to cover LiDAR very quickly. I wanted to cover this section simply because I don't think many people were, I think this is one thing that people are still occasionally surprised to find out that we support. But LiDAR ArcGIS Pro primarily does give you all the tools that you need to consume and manage your LiDAR data, as well as produce products that will further enhance your GIS work. It lets you work with LAS data sets to manage multiple LAS files at a time instead of just one at a time. It lets you produce statistical information to better understand your LiDAR, gives you tools for extracting point clouds and compressing point clouds, and it also gives you tools for preparation to edit your point clouds, classify them, and colorize them. And then, of course, as has been the theme of today, we're sharing, we're interconnecting it, so it allows you to share these point clouds as scene layer packages to ArcGIS Online and ArcGIS Enterprise so that they can be viewed in the web and then across the platform as well. It's interesting to note also here as well that we're not just providing support for traditional LiDAR, but those point clouds that Drone to Map and SiteScan generated, which sometimes is referred to as FODAR, these tools are able to work with those generated point clouds as well. So there are various different products that we can generate from LiDAR within Pro, different tools and solutions to create digital elevation models, such as your terrain models and your DSMs, very similar to Drone to Map. And it is jumping ahead on me. I guess that's a time slide, sorry. But you're able to generate different contours, hill shades, slopes, different derivatives for hydrological and solar instances, as well as some feature extraction. So one of the greatest advantages of LiDAR is adding that 3D element to your GIS. We live in a 3D world, so it helps to gain that 3D perspective to add to your analysis. So some of Pro's LiDAR tools will allow you to do things like extrude rooftops and extract building footprints for extrusion. So it's very helpful in those respects. Show a very quick video. It's only a couple of minutes long about some of the things we can do with LiDAR. So with this LiDAR data set here, first we can do is change its appearance. So if we're showing elevation to start, now we can change the symbology to classification. We can see from this, looking at this data set, it's already classified pretty well. We get pretty good indication of that stadium, what it is, and it's showing the difference between the ground, buildings, trees, and smaller vegetations. There are tools available in Pro for automated classifications of buildings, ground, and overlap, etc. And what we're going to do here is we're going to create a profile view of this data set so that we can focus on just one area at a time instead of the entire large LIS data set. We can easily adjust the depth of that as well. Now, if we do some further examination of this building here that's next to the stadium, we can see that some points have been misidentified in the automated classification. So we use the interactive edit tools to manually change the classification of those points by selecting the appropriate field and identifying them by drawing the area. So now it's fixed to identify as building. So the next part of this video shows a more advanced workflow showing how you can extract building footprints from LiDAR. So first we can filter this LIS data set to just show the points we want by classification, in this case the buildings. From there we can use a geoprocessing tool that let us use LIS point statistics to a 2D raster layer. And then once this tool runs, we can see that it's generated that raster layer of the building footprint. We can clean it up a little bit with a raster function. And what this raster function will do is it will fill in the holes within all of this raster data. So we'll run that really quickly. You can see it fills in a lot of those holes for us. And then from this adjusted raster layer, we can now generate polygons from those rasters using a geoprocessing tool. This will give us the polygon layer that we need to be able to extrude those footprints in a 3D layer. So we have those polygons now. We can use a 3D analyst tool to clean up some of the undesirable artifacts in those footprints. And then if we can skip ahead in the video, we can show you what some of those 3D outputs will look like. And then there are additional LiDAR workflows that allow for things like roof extraction for a better 3D representation of these areas. Sky's really the limit with that. But I just wanted to introduce you and make sure that you were aware that we can do LiDAR analysis in ArcGIS Pro. So that concludes our webinar. We're only about 4 minutes over, but I can stay on for about 5 more minutes if people want to hang around, and we can take care of some of these wrap-up questions. So Margie, do you have anything else for me?
Kurt and Tim have done a great job of answering questions as they've come in. So we're actually all wrapped up on the questions.
Fantastic. So thank you for joining me today. We'll follow up with an email to all of you that and get you our information if you want some more information about these workflows. But yeah, thanks for joining me, and I'll turn it back over to Margie just to finish up.
Oh, you did a great job wrapping it up. We'll send out the slides, the link to the video, and I see that we have a few more questions coming in, so we'll address those questions
Great.
afterwards as well. So thanks, everyone. Have a great day.